Hello everyone, I'm Kushal from Indeed Inspiring, and we have been discussing the probabilistic method of learning in machine learning. So we have seen the concept of conditional probability, we have seen some examples, and we have seen what is Bayes' theorem and how the Bayes' theorem is derived. This is a quick revision in one slide. So you can see the Bayes' theorem here. Bayes' theorem says the probability of A being true given B is true is equal to the probability of B being true given A is true multiply probability of A being true divide by probability of B being true. And here you can see the first expression, probability of A being true given B is true, is called as posterior. Then probability of B being true given A is true is called as likelihood. Probability of A is called as prior, and probability of B is the denominator, and it is called as marginalization. So today we are going to discuss about naive Bayes, and therefore we are just having a quick revision of Bayes' theorem. So naive Bayes classifier. So in machine learning, it is a family of simple probabilistic classifiers, and it is based on applying Bayes' theorem. Okay, so now you understand why we were revising the formula of Bayes' theorem, because naive Bayes classifier is actually coming from or derived from Bayes' theorem only. Okay, so let us look at now equations. So assume that you have data sets. So here you can see you have data sets, and you basically represent the data sets like this. X is equal to x1, x2, x3. So these are your features till xn, n number of features you have, and you represent your y as y. This is the output. Okay. So you have data sets, and for these set of features, for some parameters, you will get some value of y. Okay. So for example, whether you scored good marks or not, so how that will depend. So let's say that depends on how much you study. Let's say 2 hours you study, and then how much you play. Let's say 1 hour you play. How much time do you give for homework? Let's say 3 hours you give for homework. So these certain parameters will decide that how much do you score. So let's say you scored 89. Okay. So how it is being identified based upon the some parameters which we have. Okay. Right. So now let us put this particular scenario into the Bayes theorem we have. Okay, so once again, just look at the Bayes theorem formula. This is the Bayes theorem formula, and how we are fitting in the concept which we have the data set into the Bayes theorem. So the Bayes theorem can be modified as, you can see here, can be modified as probability of y, because the output is something which we want to find, right? So probability of y such that x1, x2, x3 till xn are already given. Okay, so this is how we can represent. Okay, so because we have multiple features, so x1, x2 till xn, so probability that they are already given, we have to find the probability of y. Okay, now understand on the right hand side. So on the right hand side, you have multiple expressions now. So probability of x1 says that y has already occurred, probability of x2 says that y has already occurred, and similar way x3 says that y has already occurred until xn. Okay, so the expression has been changed into multiple expressions now, and at the end we have probability of y is getting multiplied to all of them. Okay, divide by, again you have probability of x1, x2, x3 till xn. Okay, so this is how the formula of Bayes theorem, okay, is getting modified. So b here is basically coming as x1, x2, x3. Fine. Okay, so I hope this much is clear and understood, right? Let's move ahead now. A little bit maths about the naive-Bayes classifier. So here we have probability of y such that x1, x2, x3 till xn has already occurred, they are already given, is equal to, this is coming from the previous slide itself. Okay, now we can reduce the numerator into this expression. Okay, so pi of I from 1 to n, probability of xi such that y has already occurred. Okay, so this is something, reduction of this particular expression into short way. Okay, this is something we can do, and into probability of y, that will be as it is. Okay, so the only thing is expression has become simpler and understandable. Okay, divide by probability of x1, probability of x2 into probability of x3 till xn. Okay, so we have got the reduction of the numerator. Now for denominator, if you see, so for all x1, x2, x3, this is going to remain a constant. Okay, so we can treat the denominator as constant. So as soon as you treat the denominator as constant, what happens? So now you understand your probability of y such that x1, x2 till xn are true is directly proportional to the numerator. Okay, so this probability is directly proportional to the numerator because the denominator was a constant. Okay, so in this case, what we need to do is the y, the output in this case is equal to argmax. So we have to identify argmax here. Okay. So what is argmax? Argmax we will get from here. Okay. So the maximum value we are getting from this expression will be the output. Okay. So that will be the output. So this is the maths behind the Bayes classifier, or we call it as naive-Bayes classifier. So thanks for watching. If you have any query, please write down in the comment section. We would be very happy to come back with another concept and help you out. Thank you. Thanks a lot.